Okay, we're going to introduce to you today two of the main methods for solving simultaneous equations. There are more, but these are the main ones that come up. So the first one is called substitution. That's the first one I'll demonstrate. The second one is commonly called elimination. That's where we have to add or subtract equations together to eliminate one of the variables. But let's start with substitution. With substitution, we're going to use the same equations both times so you can see that each one works just as well as the other. I want to have an x equals or a y equals, whatever letters are involved, equation. So the first thing I'm going to do is actually rewrite the second equation so that it's x equals y plus 1 or 1 plus y, doesn't matter which way around those are, just so that I've now got an x equals equation. So essentially I know that x is equivalent to 1 plus y. Now, for this method, all I'm going to do is go to the second equation, the first equation, technically the top equation, and I'm going to substitute that in for x. I'm going to have two lots of, and where x is, I'm going to put 1 plus y plus the 3y that was already there plus is equal to the 7. Okay, so everything else about the equation is the same. I've just swapped the x out, and I've put the 1 plus y in its place. Okay, that's all that's happened. Right, now let's expand that bracket. So we're going to have 2 times 1 is 2. 2 times y is 2y. Still got a 3y on that left-hand side, and I've got it equal to 7 on the right. Right, let's simplify. 2 plus 5y makes 7. Let's subtract 2 from both sides, so that we know 5y must be equal to 5. And now we can just divide by 5 to isolate what y is. So y must be 1. Okay, again, we've got one of our variables now. We know what one of them is. So let's substitute that into one of the original equations. So I'm going to go back to b. I'm just going to pop that in red. And I'm going to put in x is equal to y. Now we know y is 1, so I'm going to swap out the y for 1 and equals 1. So now I can solve for x. If I add 1 to both sides, I can see that x must be equal to 2. Now, whenever you're doing simultaneous equations, always just double check. Pop your answers into the other equation, the one you didn't use to find your second variable. So I'm going to pop it into equation A, and that tells me that I should have 2 times by whatever x is, which is 2, plus 3 times, try that again, whatever y is, which is 1. And that should, in theory, give me 7. So if that works out, I know that I've got it right. So 2 times 2 is 4. 3 times 1 is 3. That does equal 7. So I know that I've got my two solutions or my two variables correct for this simultaneous equation. Now we're going to solve this same problem, but we're going to use the second method, which is elimination. So we know already what the answers are, so we won't go through the checking again. I might make that look more like a y though. So what we'll do is we're going to try and isolate or choose one of the variables, I suppose, to be eliminated. Okay, now when we look at an equation, we want to see if there are two that are already of equivalent size. So like for instance, if there was 2 lots of 2x, or if there was 2 lots of 3y, but we haven't got that with this example. But that's okay. What we can do is choose to either scale up 1 or 2 of the equations. We just have to be really careful when we do it. So my easiest option is to multiply the second of these equations by 2. Okay, so the first one I'm going to keep exactly as it is. Okay, sometimes you need to multiply both of them, sometimes just one will do. So I'm going to keep this one as it is. So it's 2x plus 3y equals 7. But b, I'm going to make a variant. Okay, so I'm just giving it a slightly different name. So this is now bi or b1. And I'm going to multiply everything in this one by 2. So 2 lots of x is 2x. 2 lots of negative y is negative 2y. And 2 lots of 1 is 2. Right, with the elimination method, I now need to try and get rid of either the x's or the y's. So I need to decide whether or not to add the two equations to do this or subtract them. Now, the way that we do that is we already know, hopefully, that we're eliminating our x values. Okay, we're going to get rid of those. These two x's are both positives. So if you have got the same sign, both positive or negative, then we must subtract. Okay, that's the way of remembering what we're going to do. Okay, apologies if I take any of that off. So I'm going to subtract. If you had two different signs, so for instance we were looking at the y's and they happen to be equivalent, one's positive, one's negative, so we'd add to eliminate. But as it happens, we're getting rid of the two x's. So 2x, take away 2x, there's no x's at all, and therefore it is eliminated, and that is the whole point. Then I'm going to take 2y, no I'm not, I'm going to take negative 2y away from 3y. Now if I take away a negative, it's the same as adding, so that gives me 5y, and I must take 2 away from 7 also, so that gives me the 5. Okay, this should start looking familiar now. So to find y, I need to divide both sides by 5, and therefore I end up with y is 1. And don't forget, this is where we then substitute back into one of the equations. We've gone through this process already, but just here's a quick reminder. So I'm going to put this into b, so x will be equal to minus 1 because y is 1, and that will be equal to 1, so x must be equal to add 1 to both sides, 2. Okay, and then don't forget, you would just go through the same checking process that I've already run through with the substitution. So these are two of the most common ways of solving simultaneous equations. Substitution, where you find out what one of your variables is equal to and substitute it into one of the other equations. Or we can take the second option, which is to make equivalent values of your variables and then either add or subtract, depending if it's positive or negative or the same sign, and then find the second variable again by substituting that first one back in. Okay, best of luck with these. They're well worth practicing.